Bienvenidos de nuevo a la última jornada del Congreso, donde nuestros ponentes seguirán compartiendo
Welcome to the last day of the Congress, where we'll keep hearing amazing speakers. We don't want you to forget about our hashtag. Please share it and mention us on social media. Today, the panel regarding tourism, technology, and for diversity will be moderated by Stefan Junstrad. We'll talk about smart cities and universal design to make cities more usable and accessible for the whole of the population. We would like to encourage you to watch it together with the 8 previous one that we have uploaded through this week. Today, our keynote speaker will be David Baines, director of David Baines Access and co-founder of Global Symbols. Nowadays, he works all over the world, including projects for low and middle-income countries in Africa and South Asia to foster implementation from accessibility and inclusion from politics to practice. And we'll close with a roundtable under the title, The New Scenario on Mobility. David, welcome. The screen is yours.
Thank you so much. Hopefully you can see my screen. I'm hoping that you can see the slides, which are certainly more important than my face. And thank you so much for the opportunity to join you today. And it's very interesting to me that at this time, as we come out of the pandemic, that we're discussing again the importance of travel, transport, and mobility, and really beginning to understand how the impact when the freedom to travel is more limited. And I think that helps us understand the experience of people with disabilities for many years and the restrictions and limitations under which they've moved in the past. So when I talk today, I want to very much put that into that context and apologize to you first for my lack of Spanish. But what I'd like to do is really to draw upon the research that was done for the EU-funded TRIPS project, where we really began to explore how innovation and emerging and new technologies could impact upon the capacity for people to travel. And that really started by understanding the barriers to travel that people experienced. And these were, we understood that journeys involved a number of stages, from planning to booking to boarding to the experience on board and arriving and departing the destination. And at any one of those stages, a barrier could emerge, and sometimes those were unanticipated. And we understood that some of those barriers were critical and could completely prevent a journey taking place. Others were more disturbing or even irritating and could only be overcome with significant effort. Those that were only annoying or minor still created frustration without disrupting a journey, but cumulatively over time were exhausting. And the technology that we were beginning to bring to bear upon these challenges could be divided into two groups. There were those that were assistive technologies that were designed to specifically address the needs of people with a disability. And there were accessible technologies, which were designed to meet the needs of all users, including those with a disability. And this latter group were linked closely to concepts of universal design. And it was drawing upon both of these areas that we began to apply this to the barriers that allowed us to look at how emerging technologies offered new opportunities for the future. And I want to touch upon for a very short moment what some of those technologies are before we start to look at how they were applied. So the first technology which we found to be particularly valuable was wearable technology. wearable technology that was pervasive. It went with us regardless of where we moved to, and it could offer things from alerts and alarms, memory aids, support for safe movement. It supported us in meetings and collaboration, and supported us to have access to information on demand. The second group of technologies perhaps revolved around smart homes, what we sometimes call the Internet of Things. And this gave us independent control of the environment, supported our security and safety, allowed us to log activities, allowed us to link devices one to the other, creating more responsive and personalized environments. And we've seen many of these recently in smart homes, but actually this smart home technology can pervade right across the built environment, connecting us to that environment and from device to device. Linked to that smart home technology was the concept of location-based services. And these include GPS systems, Wi-Fi, beacons, particularly within the indoor environment. And they were critical when we began to plan and use emerging technology, because location, information, and recall, helping us to find our way from location to location, both outdoors and indoors, providing location data in the place that we received, and providing alerts around the location. And those alerts may be offered in real time, and therefore highlighting emerging barriers to travel that otherwise we wouldn't be aware of. One of the most important areas of emerging technology was around artificial intelligence. And artificial intelligence really pervaded many of the other suggestions and solutions that were considered. And artificial intelligence can lie underneath the idea of context-aware AT, where our assistive technologies and our accessible technologies are aware of the setting and the environment within which we are, and adapt and conform to that setting to give us a very personalized, individualized experience based not only on our needs, but the setting which we're living in. It was important in terms of predicting needs, anticipating needs. It supported autonomous mobility. And when travel information was complex, content clarification allowed that complex information to be simplified and presented in a way that was easier to understand. And of course, artificial intelligence lies under many of the automated processes that we use for accessibility, ranging from captions on videos to even image recognition and alt text on websites, web pages, and images. But some of these were particularly important to us. The idea of content clarification, of predictive text and context, of automation of accessibility processes and predictive prompts, anticipating our needs and our intentions. When we brought these together with the power of artificial intelligence and machine learning, we could use that on a number of the barriers and stages of a journey. Other areas that were very important were robotics and drones. And robotics and drones we've seen growing as a result of the pandemic, including ideas of remote presence and telemonitoring, supporting self-care and home care, and adding security. Robotics and drones allows services to be delivered remotely. It allows us to take part in things without needing to physically travel. It certainly supports deliveries. the physical manipulation of objects over distance, and increased self-care, where perhaps the demand on human personal assistance is far less. And perhaps in some ways we've seen the value of such robotics and drones to mean that we need to travel less, such as not being able to shop, where things can be delivered to our homes. But in practice, actually, we're going to look at some examples where robotics and drones have an impact on journey. The next group of emerging technologies that we really looked at, we called enhanced realities. And they were a mixture of virtual reality, a fully artificial environment, an augmented reality, where virtual objects are overlaid upon the real world environment, and what we called mixed reality, where that virtual environment and that augmented overlay were combined with physical objects in the real world. So we had the opportunity to move from full immersion in virtual environments to the real world enhanced with digital objects, and a real world where what we did and moved in the physical environment created change in the virtual and augmented environment. And many of these enhanced or alternative realities have been used to relate to training, but are phenomenally important when we talk about access to information. They're also really important traditionally in the testing and review of products, but perhaps also offer us the opportunity to test and review journeys in advance of making a journey, helping us explore that in augmented and virtual reality to consider the barriers that might emerge for any one individual. But perhaps when we talk about travel and mobility, probably the one area where we have expected to see so much happening has been the growth of autonomous vehicles. And it's interesting that autonomous vehicles take many of the strands that we've discussed, the emerging technologies, and bring them together into a vehicle using images, sensors, the Internet of Things, to really combine this with mapping and navigation data to control what in effect is a drone. Autonomous vehicles are fundamentally drone vehicles that are controlled by artificial intelligence using sensors within the vehicle and within the environment. And when we pull that together, we have the capacity for autonomous vehicles to be used, which may be used by people who otherwise would struggle to travel completely autonomously. So having had a very brief introduction to some of those technologies, and there were others that we looked at, we began to take these technologies and think about how do we apply these to travel, to journey making, and to that chain that takes place within a journey where barriers might emerge. What we did then in applying those technologies is we created a series of design concepts, some of which are very close to being on the market, some perhaps a little bit further away. Some of them are big ideas, disruptive innovations, new ideas that could transform the way in which we make journeys. And some are much smaller and short term and would address the risk of a barrier happening at any one step in the planning and traveling. Both we recognize as being very valuable. To get those, we used a co-design process where we brought together transport operators, engineers, AT specialists, and most importantly, people with disabilities themselves, and drew them from a number of cities right across Europe to consider the barriers that they were aware of, their personal experience of travel, and to think about how these emerging technologies could be applied. And the ideas that people came up with through that co-design process were fascinating. Some of those ideas were relatively simple, and you might recognize them from other settings. One of the ideas was a mobile walkways across a city network, a citywide network of rapid mobile walkways where people can automatically get on and get off safely, which was a system for all travelers, but had benefits for those with disabilities and had a strong sense of inclusivity. And it really did theoretically build upon existing technology found in airports and metro stations, and the users felt it was friendly and straightforward to use. We looked at the added value such systems might have and saw how this was seen in the opportunity to reduce traffic congestion and the associated pollution in cities, creating a healthier and more pleasant environment for all. Once you've stepped on and identified your route, the pathway, the mobile walkway takes you to where you want to go. It's very simple and easy to understand. You could also see how something like a mobile walkway city network could blend and merge with the existing systems of public transport that we have within cities. It also would be very effective regardless of whether you're using a wheelchair or other form of mobility aid, or whether or not you're able to stand and walk independently. We also recognized that one of the challenges that we faced was understanding the restrictions within public transport, that often getting access to information and data when traveling independently could be quite difficult. And many of people in the discussion, particularly those with limited sight and those who found it challenging to read signage, mentioned about the importance and value of spoken information. And where we have onboard information systems currently, they're identified as being extremely useful, including those where information is put quite high on the roof, which can sometimes get blocked from view if you're viewing it from the height of a wheelchair. So spoken information was really important. But the idea of large screens with information, with the capacity to link to that, to have that information read out using, say, a Bluetooth headset, allowed us to offer a much wider range of information during a journey. It could offer more than stop announcements, but could add live information about congestion around a metro station and the surrounding areas, and suggest pointers about the best way to leave the vehicle or station for those with limited mobility, particularly if entrances were congested, or if the area above ground on a metro was difficult to get around at that particular time. Then knowing which route to take out of a station could have large amounts of extra value. One user talked about this as being a little like having audio description for the real world, delivered through a mobile phone to a headset, reducing disturbance to other travelers alongside shared information. Possibly the best example that anybody gave us was simply being told that the station they had planned to leave, that the elevator had stopped working. So rather than getting off and discovering that, they were told to move to the next station along the line, which was actually much quicker and easier for them to get to their desired destination. That was about reducing frustration, that emotional impact when journeys go awry. The third area that we looked at was travel planning apps and the importance of travel planning apps for everyone. One of the things that people with disabilities highlighted to us for travel and mobility was how much extra time it took them to plan a journey. Currently, often information is held in multiple locations, but transforming this into a single process allows planning technologies to reflect a need to be seamless. We understand that applications that plan travel should recognize that barriers to mobility vary from person to person, and that helps us increase autonomy. So travel planning apps that brought together data and analyze that using artificial intelligence, such as access to stations, accessible routes, accessibility on board, and what to do when things go wrong, helps both people with a disability and anyone with additional needs on a journey, which might include second language users, visitors, tourists, and so on, where actually having information laid out simply would make a huge difference. Being connected to the vehicles using the Internet of Things would allow us to show when an accessible vehicle will arrive and the current waiting time. Information about how crowded vehicles are might benefit those who want to avoid congestion, which could include people with autism. And then such an application would make journeys more manageable and comfortable, with less time spent thinking about travel and more time enjoying the journey. And the example we came up with, which was most valued, was applying that information through augmented reality. And this is already being done with people like Google Maps adding live view, where you can add an augmented tier over the camera view on your smartphone and get extra information about the environment around you. But when we merge data from different data sets into that live view, we get information not just about where you can get coffee from, where restaurants are, where the station is, but also whether or not this is the best or right route for you to use according to your needs. Maybe cluttered, maybe congested, maybe noisy. And you can choose the one which is not only accessible, but really matches your own personal preferences. And this idea then took us further into existing technologies, such as wearables, and really increasingly using wearables for payment and access. Already we've seen banks like Barclays introduce wristbands, which you can use for contactless payment, a variety of settings, including buying tickets and getting through barriers at stations. Wearables that allow people who are using it to pay when boarding and communicate to the vehicle that a longer boarding time is required were seen as particularly valuable. Bands are already available in some locations, and users are charged as they board and leave and don't have to deal with the difficulties of accessing kiosks or ticketing systems. Many people reported how inaccessible kiosks and ticketing systems had given them examples of when they missed a journey or even traveled illegally because of unintended booking errors. And having then to make a case and explain how the inaccessibility had created the booking error, and hence they were on the wrong train at the wrong time. Wearable would be linked to an account to improve the payments as we pass a gate or beacon when beginning or ending a journey. But we could actually take that a stage further, where the same wearable also facilitated access to vehicles by opening doors or activating a powered ramp, especially during an emergency. Not having to wait for someone to take these actions for you was seen as making independent and autonomous mobility much more powerful. They're also a way to communicate, alerting the driver or vehicle manager the disabled user is boarding and making them aware of accommodations they should make. Many people explained that when a driver or vehicle manager knew they had people with disabilities on the vehicle, they took much greater care to support them. When they didn't know, they weren't always anticipating needs. So providing information as well as receiving information could be done through the wearable in a non-invasive way. And of course, wearables are things that we're seeing more and more in our daily lives, whether they be things like Apple Watch or whether or not they're just simply fitness trackers. we're all getting used to the idea of having technology that we take with us and which is pervasive and which offers information and data regardless of our location. And these forms of wearable also offer the means of giving control to engage remotely controlled powered ramps to help board vehicles on demand. And this isn't that different to the way in which we can use wearables already to control other devices using the Internet of Things. I can control my mobile phone. I can use my wearable to control the physical environment, turning lights off, lights on. So actually we could use the same form of technology to select a command to deploy a ramp as a vehicle arose, or using location information to recognize that a wheelchair user will be at the next stop and deploying the ramps automatically. System would allow users to access as soon as they neared a door to enable self-boarding and exit, which would offer independence and again just create less reliance on having staff who were trained and knowledgeable to provide assistance. The turnover of staff in transport companies can be quite high, and maintaining their skills and knowledge can be difficult. So anything that can be done to automate that would seem to be perhaps more reliable than people may be. Gradually, we began then to expand our ideas and think about bigger ideas that could benefit people. One of the ideas that we looked at, which was in development from universities, was the use of LiDAR 3D reconstruction. And this is a very interesting technology for when you're moving around, as it uses sensors which are wearable and portable to reconstruct the environment around you. And we can then take that 3D reconstruction and convert that into sound or other formats. So by taking the signal around us, we can identify obstacles, and the traveler can be warned and guided to avoid them. The idea that this was wearable and allowed those who were blind or visually impaired to reconstruct the external environment very precisely and their position in it, including moving objects, was one of the strongest ideas amongst that group. The sense of confidence and safety were shared by many, as this technology seemed to offer a means to navigate through the built environment to access transport safely. It would help with moving between vehicles and disembarking readily and smoothly. Particularly with the growth of things such as bike lanes, which run alongside where vehicles may park to do a drop-off, 3D reconstruction of the environment could be really important in knowing that it is safe to get out of the vehicle because there's not a bike or an e-scooter or any other sort of transport coming towards you at speed from left or right. Our engineers and people with disabilities imagined smart glasses with a sensor and headphones for alerts. The glasses could share what was detected, process the information, and send the alerts and advice to the headphones. Third-party developers could offer extra information based on what the user wanted, needed. There was a commercial opportunity behind these glasses. Again, you could see how this could link with augmented reality, so not only providing alerts, but other information, and in a variety, quite a wide variety of different formats. I mentioned earlier about robotics and drones. And it's interesting, I've seen the opportunity that drones offer in other fields. I was in Bangladesh a few years ago, and we spoke about the problems of deliveries in Bangladesh. I was in a village next to a lake, and over the lake was the hospital, which you needed to go to pick up your medication. It was about half a mile away, directly across the lake. But for about 6 months of the year, the route around the lake was underwater, and it was extremely difficult to get vehicles through. So a drone flying across the lake, delivering medication to the villages, using a PIN number to unlock the drone when it arrived in the village to give people their medication and treatments, was really quite an exciting idea, and dealt with the immediate environmental barriers that were not consistent all year round. And we took this idea of drones and robotics, and we came up with the idea of what we called an assistive buddy. A travel buddy robot was a concept of a robotic device that followed the traveler, carrying luggage, could support you with information and provide support in case you needed to move from one position or vehicle to another. And for the people with disabilities involved in the design, it felt both futuristic and really quite feasible, with value to people with disabilities, but also to lone and older travelers with bags who might feel overwhelmed as they have traveled. It added a level of confidence and security to the journey, and even a social aspect of not feeling isolated while traveling, and might enable them to walk home freely after traveling, shopping, or starting or ending a long journey. And these don't have to be personal. These can be shared resources. And the sort of design of robot that we had, these small vehicles that we are actually based on robots being used in the town where I live to deliver shopping directly into people's homes. We have these small robots, which have probably come up to about just above knee high, have 6 wheels, and our local shops during the pandemic and beyond put shopping into them when you order it, and they're delivered automatically to the front door of people. By being a shared resource, they support the notion of mobility as a service. Because when you decided you wanted to go shopping, you could book such a buddy in advance on a pay-as-you-go model, which then allows the robot to return to a charging station after use. So rather than straggling with heavy bags or needing to book an expensive taxi, you could still walk to the shops nearby and use the robot to follow you home based on being tagged onto a wearable you might be wearing. It would follow you precisely until you got back. You signed it off at the end of that journey and it returned to be charged for the next user. You could see how that could be used in large airports and other settings where carrying heavy items or just carrying items through crowds could be made a lot easier. So assistive buddies were a really quite nice idea. And such robotics and drones then took us into this idea of autonomous vehicles and taxis. If you go to Heathrow Airport and you travel at Terminal 5, there are autonomous vehicles that take you from the airport to one of the large car parks. You simply walk down, you get in, you just tell it where you want to go, and following a fairly broad routeway, it drives you there and drops you off. And autonomous smart cars without a driver could be rented for personal use. They can be tailored to an individual's needs by establishing a user profile that's engaged when the user enters the vehicle through voice recognition. So, for instance, it could know the person entering the vehicle is deaf, and therefore all information needs to be provided on their smartphone visually. Or it could be that the person entering is blind, and therefore we need to give them the information about the journey through an audio signal. Or that the person has mobility needs, and when we open the doors to let them out, we will know that we need to give them longer to leave the vehicle. Linking these up reduces dependency on drivers, and shared transport seems to be a really good way of offering independence and greater autonomy of persons with disabilities when traveling. Because they're shared and they're booked on demand, They don't require perhaps quite so much advanced planning, and certainly don't require you to find a driver, both collect you and pick you up. They build very much on the model of things like Uber for on-demand services. There was a feeling that for many people it could make a journey both functional and a pleasure, as they were less concerned and worried about the transport form they were taking. Such autonomous vehicles and taxis are already being tested and trialed in some places, and we're seeing such autonomous vehicles being introduced on things like university campuses. There's another, of course, really interesting dimension to this, that all the emerging technologies that blend into this autonomous vehicle can actually also be applied to things like autonomous wheelchairs, reducing for the risk of journey making for people in a powered chair who have limited control over the controls on the vehicle, on the chair, and taking away some of that risk. And the other really big idea that people had, we talked about why is it that so many parts of the built environment are still not fully accessible to people who are wheelchair users. And we thought about the drones model. And yes, we came up with a flying or levitating wheelchair. And yet, originally, my first thought on this one when I saw this design was this was fantasy. It was science fiction. But then we began to look at the use of drones for carrying heavy loads a few inches or a few feet above the ground on building sites, construction, and other locations. And once we know that that is possible, and we know that autonomous vehicles are possible, things become quite interesting. Because vehicles that fly at very low altitude can help us to avoid traffic jams and obstacles, may be particularly effective over short distances where there are single steps or small numbers of steps. They might avoid the need for any other means of transport for power chair users, as it could pretty much go anywhere and provide complete autonomy. And as I say, whilst it seemed to be fantasy, it's rooted in actually very realistic engineering. And that included flying delivery vehicles being trialed in some parts of the world. And it seemed to be to support the opportunity to go anywhere and be flexible whilst avoiding obstacles. Clearly, there are many barriers to overcome. A need for some parts, the vehicle to act autonomously to ensure that there was safety and protection for travelers and those around them. But it seemed likely that in the not too distant future, perhaps some of these prototypes will emerge onto the market. Certainly within even my life. So we took these concepts, and this was just some of the concepts that people came up with that use those emerging technologies at either that small or large scale, and then working with policymakers and transport companies, began to draw up a list of what were the barriers to implementation. Because it wasn't simply the engineering or design that was the barrier. There were other factors that needed to be brought to bear. The first, and perhaps that's why we're talking today, was awareness that many of the innovations that we've talked about are technically and economically feasible. But many of the key stakeholders lacked awareness of the challenge and the potential resolutions. How do we mitigate some of these barriers to design and implementation and make them useful for people? Without knowing what was possible and the potential impact, it's very difficult for bodies to act. Information about what was available was often only available in technical journals and often only in English. So some of the places that would most benefit from some of these innovations, access to that information was more difficult. So making resources and ideas widely available and accessible helps stimulate awareness. As we stimulate awareness, we create more positive attitudes towards change and innovation. which makes those changes more likely in the future. The second area that many people talked about was many of the designs are perceived as being expensive. But we realized as we looked at the analysis more carefully that cost was offset by a number of savings. There was less dependency on human labor. The environmental savings were significant. And this came with increased usage. And of course, the extent to which the innovations used existing technologies impacted on cost. So the underlying technology trends, such as wearables, such as drones, much of the development cost has already been done. We're now into implementation and designing for a particular user case. And we really needed to understand the extent to which the innovation brought comprehensive benefits to all travelers, because this reduced the cost per user. It made it much less that accommodating needs was a financial burden for what was perceived as a small group of users, but instead included them in the total cost to benefit all travelers, making the cost per disabled user no greater than it was for anyone else. So there are a number of ways in which we could understand and mitigate cost. And understanding that broader dimension of cost-benefit analysis and the savings that we would make, as well as the expenses we would incur, was very, very important in future planning. Political will was the next dimension of barrier to implementation. Everybody around the table felt that investment would only occur if inclusive mobility and the community recognized the benefits, and that those benefits and those communities had political and social support. And that meant support from the wider community within which people with disabilities live. One of the reasons why I'm so pleased to be talking here is to recognize the role of disabled persons organizations goes beyond making politicians aware of the need and even of the solutions, but really includes a persuasive business case. Really making it clear how this helps us meet not only our commitments to people with disabilities, but perhaps some of the commitments made at things like COP26 and elsewhere as well. And with that really came being clear and sharing perceptions of added value. And this was challenging because it was a double-edged sword. The extent to which designs offered added value needed to be understood quite carefully. How far a solution made travel easier, more comfortable, safer or faster, added weight to the case for implementation. And of course, added values such as reducing congestion, environmental impact, and safety were highly regarded and helped us harness the community, the wider community, to bring social pressure for change and investment. But we were also conscious that measuring innovations through added value could detract from the focus of enhancing and increasing mobility for those with disabilities. And that had the risk that perhaps we invested in solutions that failed to address the central challenges that people with disabilities faced. And whilst there might be some incremental improvement, reduction in frustration, the underlying challenge and barrier that people faced was not addressed, and there was no real substantive change in travel and mobility. And we come back to where we started from. Without inclusive travel and mobility, not only does tourism become impacted, but access to employment, access to education, and access to social and cultural life and the ability to live independently are all reduced. So in taking those added value dimensions and bringing them to bear, it's very, very important that we don't ignore the core purpose of inclusive planning. Technical feasibility did have to be considered. We did encourage our stakeholders to dream, and they found it difficult to dream, to think in the longer term. People with disabilities have faced so many barriers to travel and mobility that it's difficult to think big, to think long term, and instead you tend to focus on what could be done in the very short and quick term. But those were the ideas that were more technically feasible. All of the ideas that were designed and shared addressed barriers, but some could be delivered much more quickly than others. So we had to ensure that we understood which emerging technologies were being leveraged for the design concepts and the extent to which those ideas could be brought to bear quickly. That took time. And one of the things I would really advocate for disabled persons organizations is to try to bring to bear an understanding amongst the people with disabilities and their community about what these emerging technologies are. Yes, to recognize the risks that we face in using these new technologies, but really to encourage a positive approach to understanding what these technologies could do. Disney always used the term to describe the people who created their new rides, Imagineers. And people with disabilities need to bring imagination to the barriers, because imagination of using real and emerging technologies is what leads to implementation and application. It was the most fluid of barriers. Technical feasibility changes every year. Concepts that were science fiction less than a decade ago are in the real world being tested today. So just because something seems unrealistic today doesn't mean that we won't see it in our lifetimes. As we come to an end, I know I want to take a little bit of time to offer you a chance to ask questions and make comments. There were many ideas that came forward through the co-design workshops with all those different stakeholders. They were ideas that were a mixture of big, imaginative, disruptive concepts that could change everything about a journey, and smaller incremental ideas that could remove barriers to one or more stages in that journey. But they share a single purpose. Freedom of travel and mobility should not and does not need to be denied to anyone as a result of disability. And with that thought in mind, I think many of these design concepts can be taken forward in the future. I want to close there because I want to make sure that I've left a little bit of time for questions and comments. If you want to know more, if we run out of time today, do please contact me by email or through various social media, and do have a good look at the tripsproject.eu. There's a much wider range of materials as we go into the final year of that EU-funded project. With that in mind, over for any questions.
Muchísimas gracias, David, porque sí que tenemos
David, we do have some questions from the audience. Let me read them out to you as long as we have time. How will we include the older generations in the use of these travel applications?
I think that's a really good question. But I think part of that falls under this idea that those innovations that impact on the widest community are the ones we will see around us most quickly. So I think that idea of accessible technology that is used by many, many people. For instance, we know that older people are quite taken to wearable technology for things like fall detection, because it makes it very easy. They've taken it to ways of supporting for ambient living and living at home at times when in other when at other times they might have had to go into care homes. So I think the wider we see those new and emerging technologies being applied in daily lives, the more the older generation will embrace that. And it's the use of consumer technology, which I think is really helpful. Many older people have taken to things like Alexa very quickly because they're such a natural interface. You don't have to learn to do very much to use Alexa. If you can speak, you can access information, or you can control your environment. So ease of use is a really important factor in supporting and encouraging older users to benefit from these technologies.
Gracias, David.
Thank you, David. Here's the next question from the Accessible Tourism Network. Great part of technology seems to eliminate workers, for instance, people who work in transport. Have you considered ways to incorporate these people and make travels more safe for everyone? Have you taken this into account for all of them as well?
Yeah, I think that is a really interesting challenge. I think what it begins to allow the people who are working with the industry to do is to really focus on providing the quality of interaction that people need. Because if we're taking away some of the more fundamental and basics of travel and journey making, then it means that we can use those people to really enhance the journey for people with disabilities. One of the things that was really interesting, we were talking about the autonomous vehicles, and there was some people in the groups who weren't that keen on the idea of traveling autonomously by yourself in a vehicle. Because traveling on a bus, a tram, a metro, one of the things they got out of that was the social interaction with the people around them. It was a very social setting. So yeah, there were some risks there, but I think at its best, it says, okay, let's stop using our people to deliver a basic level of service. And let's really use them to add that real human quality and warmth to a journey, which perhaps they don't have the time to do for every passenger currently.
Y hablando de expectativas, ¿pueden algunas de estas...
Speaking about expectations, can some of these technologies, such as the self-driving vehicles, create false expectations?
Oh, I'm sure that you're absolutely right. We have to be realistic, and not all of these can be done at once. So I think, one of the things that is really important to do is to think of this as short, medium, and long-term interventions. So the things that we can do quickly and easy. And I think things like the wearables for paying, getting through kiosks and not having those errors, things like the transport planning apps, which bring together the data sets to make planning quicker and easier. Understanding barriers to a journey and communicating that and changing a journey's directions in real time. Actually, things that could be done quite quickly and easily within transport. But you're right, things like the autonomous vehicles are probably longer term. But as I say, things like the assistive buddy for me would have felt like science fiction 2 years ago. But then most days, if I walk out into my town, I will see those robots delivering locally. So all of a sudden, that seems very, very feasible.
For people with reduced mobility, for instance, technologies allow them to do things, but is there a risk? Is this only available for developed countries then?
I think with all new technologies, that is going to be one of the challenges. But I think, and some things, particularly things like the autonomous vehicles, the mechanical things, are maybe particularly problematic in some cases. But the things that involve artificial intelligence, one of the great things about those technologies is that they are so scalable that actually we are seeing, even in low and medium income countries, increased growth of things like smartphone penetration. I was working with refugees a few years ago, and even coming out and fleeing Syria, Iraq, and so on, one of the things that they took with them and guaranteed, and I met them and I saw their smartphones wrapped in sellotape to hold them together, was how crucial that technology was. It was one of the things they most sure they took with them when they ran. So actually, those technologies are pervading very widely, and we can use that availability with technology. I think what's more problematic is making sure that we have infrastructure in place so that these signals and so on can be used. But these may actually offer lower cost ways of ensuring inclusion than some of the older traditional approaches, because we've certainly seen that in other areas. For instance, the distribution of Braille books is really expensive. The distribution of digital accessible books that can be read out loud on a Braille reader is much, much cheaper, even in low-income countries. So sometimes, whilst it sounds like it's going to be a lot more expensive, actually the traditional and older technologies are actually really expensive, particularly where they're designed specifically for small groups of people with disabilities, rather than being accessible to all people, including those small groups of people with disabilities.
Y hablando de tecnología
And
asistencial,
talking about assistive technology and accessible technology, is it possible to mistake one for the other?
Oh yeah, and lots of people do. And it's really weird, odd, because it's quite possible for technology to be both. So we've been doing some work recently on smartphones, and here's an interesting conundrum. If you're using a computer and you need a screen reader, then the screen reader being purchased separately from your computer is viewed as an assistive technology. And people will pay for JAWS, or they'll make NVDA accessible, or other screen readers. But if your screen reader is built into your mobile phone, it's an accessibility feature of the phone, not an assistive technology for funding purposes. So we have this real confusion about what is assistive and what's accessible. And I think when we come into design, funding, and provision, over the next 2 or 3 years, we're going to need to move away from thinking about the difference between the two as being around the specification, and actually thinking the critical thing is, do they help the user achieve the task they want to achieve? And if they help us achieve the task or goal, then they should be something that we seek to provide, rather than thinking, no, that's not, we don't provide that because it's an accessibility feature rather than assistive technology. The purpose should be the driving force. And I think that's just as true for these technologies. When we talk about autonomous vehicles, for instance, the question shouldn't be, is that an assistive technology? But if it's got all of those features, such as audio description and so on in the environment built in, if that helps people with disabilities to move more independently, we should support it as part of a provision for people with disabilities, even though the rest of the population will benefit from it as well.
muchísimas gracias, David, por haber
Thank you so much, David, for being part of this Congress and for providing us with your vision on how well-used technology can eliminate barriers in travel and tourism. During today's pause, we'll see a video regarding the importance of accessibility in culture. We hope you enjoy it.